Alright, so this is part 3, last part of our series on mole conversions. These are some longer problems, but the nice thing, they break down into what you've already done. So it's just a matter of paying some attention. I'll be doing these problems, one in one color, one in the other, so we can see kind of how they're related. They're really just going to be sort of opposites. So if you want to do one in one color, second one in a second color, by all means do that, if that'll help you out. But in the first case, even before starting example 1, is there a direct link between grams and particles? And if you think about all the problems we've done up to this point, there has only been one unit that is constant in each, and that is mole. In any of these problems, we are relating something in terms of moles. And so that might have been in the first case how we did molar mass in grams, or in terms of number of particles. Avogadro's number of particles. But either way, we've related these both to moles. And so the reason this idea is important is going to show up in these problems. So like now with example 1, how many grams are equal to 6.75 times 10 to the 25th formula units of calcium hydroxide? So we have our number, 6.75 times 10 to the 25th formula units of calcium hydroxide, keep it all there. So let's write this down. Nothing to 10 to the 25th. And then we're going to take that over unitless 1. And on our continuum here, since we're starting with formula units, we're starting over here on the right. And eventually we're trying to get grams. We want to make our way leftward in order to do that. So the first stop has to be to get this in terms of moles. There's a stop at moles prior to molar mass. So let's do that. We're in terms of formula units. They are 6.02 times 10 to the 23rd particles. Formula units are a type of particle. And that's equivalent to 1 mole of anything. In this case, formula units of calcium hydroxide. So this is not really that different from what we did in part 2. We have to do some division. 6.75 times 10 to the 25th divided by 6.02 times 10 to the 23rd. And there's a fair number of moles. This is 112, or you might have it written out 1.12 times 10 to the second, depending. But that's how many moles that we have present in this sample. So we're here. We're in the middle, but we're trying to get ultimately to grams, which means now it's molar mass time. So use the information we have. We have a new starting number. You just solve for it. We know that our sample contains 112 moles. And now we're relating this to grams. We need to use molar mass again. So calcium hydroxide we've actually already used. But let's place our units. So we want moles to cancel out, grams up top. 1 mole of calcium hydroxide was 74.1 grams. So take a look. Moles are going to go away. We are left with grams. And we're just going to multiply these top 2 numbers to get what we need. So 112 times 74.1 gets you 8,299.2 grams. And this is calcium hydroxide, which, sounds like a lot. That's a pretty big number, but grams a pretty small unit of measurement. This is like 3-ish pounds, maybe a little bit more. So nothing too crazy. So we're almost out of the woods here. We've got one more to look at, and I think this one's a little bit nicer to do. I would switch colors if you're going to do 2 colors. Switch this over to green. So how many molecules are in 16 grams of carbon tetrabromide? We've got our question. We want to end up at molecules. We have our initial value of 16 grams. So we'll start off with our initial value as we've been doing, 16 grams, CBr4. And let's take a look back at our little continuum here. Now we're starting with grams. We're starting not on the right, but we're on the left side this time. And so molar mass is going to be more useful in that first step to get us to moles. So let's do that. We'll go from grams to moles. We'll use molar mass. Set this up. And so grams will have to cancel, so that'll go on the bottom. Moles are going to be on top. And for the carbon tetrabromide, we have 331.63 grams is equivalent to 1 mole. So you look at this, we're dividing this times 16 over 331.63, and you can run that through. And we got 331.048 moles. And this definitely makes some sense. Our sample, 16 grams, 1 mole's worth over 300. So we should expect to get, our sample is much, much less than 1 mole. But, okay, we're at moles now. We are at the middle of our continuum here. We want to convert this into molecules. We want to solve for particles. So we're going to be using Avogadro's number, the 6.02 times 10 to the 21st. So take our unit, express this in terms of moles instead. And before we plug in Avogadro's number, let's just make sure the units all match up. So we want moles to cancel out, and we want to solve ultimately for molecules. Keep those abbreviations straight. Okay, by definition, 1 mole is equal to 6.02 times 10 to the 23rd molecules, and we can multiply. Don't have to worry so much about the denominator because both of them are 1. We can see moles are going to cancel. We're left with the units that we are solving for, which is molecules. And if we multiply through 0.048 times 6.02, 10 to the 23rd, we end up with 2. Should use the color I started with probably. There we go. 2.89 times 10 to the 22nd. And this is molecules of the carbon bromide, the CBr4. So that's it. This is as bad as these get, these 2-step problems, and we've seen both options here. So there are practice problems at the end of this assignment. Please use the resources we have, both 6.1 for molar mass and all these examples we did to get those complete. And like I said, this is all I can ask you. We've seen every type now. So hopefully this has been helpful, and best of luck.